is RF. It is also known as the ripple factor, or it is also denoted by the small r over here. Okay, so we know that the ripple factor, it is nothing but the amount of AC upon the amount of DC at the output, that is RMS. So I can straightforward, I can write down the equation, that is nothing but a VL RMS square minus VL DC square raised to half, raised to half, whole divided by VLDC, whole divided by VLDC. Okay, now we can substitute the formula already which we have derived over here. So we have got this formula over. So once we substitute this, we are getting here as Vm by root 2 bracket square minus 2Vm by pi bracket square raised to half, and that is 2Vm by pi. You can take all Vm outside the bracket. So on solving we are getting this as a ripple factor, or small r equals to, if you solve this, you will get this equation over here, raised to half, that is a pi square by 8, which is nothing but 0.48. And if you multiply by 100, so if you want a percentage of ripple factor, or a small r equals to 48%. So for full wave rectifier, the ripple factor is 48%. If you compare with a half wave rectifier, it was 121%. So the next parameter, my friends, we have got, that is a rectification efficiency. So my dear friend, the next parameter is rectification efficiency. Okay, that is 6 number. The rectification efficiency is also denoted by neta, which is equals to output DC power upon input AC power. Okay, so PADC upon PAC. So we know the output DC power is nothing but IL DC square into RL. So I have used a formula that is power is equal to I square R, or sometimes there is P is equal to V into I also. So I have taken I square R over here. Now PAC is nothing but ISRMS square into source resistance plus rectification resistance plus load resistance over here. Okay, now we can substitute this value. Already we have derived this value over here, so we have got this value, we just substitute it. So is equal to ILDC. So okay, what is ILDC? So here we have got this formula. So this is nothing but a 2 RM upon pi bracket square into RL whole divided by IM under root 2 bracket square into RS plus RF plus RL. Here in this, as RL is very greater than RS plus RF, we can neglect RS plus RF. Okay, so in short, we can write this as 4 RM square upon pi square into RL whole divided by IM square upon 2 into RL. Okay, so what happens over here, the RL or RL also get cancelled over here. This 2 will go above over here, it will get multiplied by 4, it will become 8. Okay, 8. So I can write this equals to 8 uh, sorry, 8 RL, not 8 RL. So this can be equals to 4 RM square upon pi square. Now this term will go above, so it will be into 2 upon RM square. So what will happen? This and this will get cancelled automatically, and 2 2s are 4, 2 4s are 8, which will be equals to 8 upon pi square. So what is 8 upon pi square? So if you take a calculator and you can solve this, 8 upon pi square is nothing but 0.812, and if you write the in percentage, so it will become 81.2%. So I can write here the rectification efficiency for full wave rectifier, it is 81.2%. Okay, so the next parameter is TUF, that is nothing but a transformer utilization factor, which is nothing but a DC power. Okay, already we have discussed in the my last video, that is a DC load power upon power rating of transformer secondary. Okay, transformer secondary winding over here. So this can be written as RLDC into VLDC. Okay, that is a DC power upon ISRMS into VSRMS. Okay, so this is a transformer secondary, my dear friend. So this ILRMS and VLRMS is different, and this ISN, this is somewhat different over here. Okay, so both are AC power over here, which can now substituting the value of this we get. So ILDC is nothing but so let us substitute the value, that is 2 Vm by pi into 2 Im by pi whole divided by Vm by root 2 into Im by root 2. Okay, now if you solve this, okay, if I take this if I'm solving this, what we get, we are getting 8 upon pi square, which is equals to 81.2% over here. So this is a TUF. Okay, so the transformer utilization factor for a bridge rectifier. So this 81.2% is a transformer utilization for the bridge rectifier, full wave bridge rectifier. Now there is one more rectifier, that is a full wave center tap rectifier. Okay, which consists of two diodes. Okay, but a transformer utilization factor for a full wave center tap rectifier is different, and full wave bridge rectifier is different, because here you consider four diodes, and here what we are going to get, it is for a two diodes. So TUF for a center tap rectifier, I'll just write here center tap, is equals to nothing but, so it is calculated as, so transformer utilization factor for a center tap full wave rectifier is nothing but, we can say that it consists of a so I'll draw the diagram over here. So if you see, and here it is a load RL over here. Okay, with respect to this. So if you see, this is the secondary diagram of this, which is connected over here. So here you got one half wave rectifier, here you have got a second half wave rectifier. So there are two half wave rectifiers over here. So the TUF for full wave center type rectifier, it is different over here. Therefore here we have to calculate it separately for a primary and for the secondary over here. Okay, now how to derive this. Okay, now I'll just write here, therefore TUF of primary winding equals to 2 into TUF of half wave rectifier. Okay, we know the what is TUF for half wave rectifier. We have calculated it is 2 into 0.287. Already we calculated, so it becomes 0.574. In my earlier video, we have calculated a transformer utilization factor for half wave rectifier and we got 0.287. Okay, now therefore the average TUF equals to TUF primary plus TUF secondary divided by 2. So it becomes 0.574 plus 0.812 divided by 2. So average TUF equals to, we are getting 0.69693, or in terms of percentage we are getting it is a 69.3%. So this is a transformer utilization factor for uh, full wave center depth transformer. So I can write here the TUF for full wave bridge rectifier, it is 81.2, and for center tap it is 69.3. So my dear friend, for more technical video, please like, share and subscribe to my YouTube channel. Thank you.